And we're live. Yeah.
Okay. Yeah. Actually, yeah. Hello, everyone. Good evening. Yeah. First of all, I thank the student community of DIT for providing me this opportunity and share my experience of the Internet of Things with you all. Okay. Actually, I want this session to be a interactive one. Okay. Yeah, so that only it will be good, and actually you can also get some lot of information from me, and I can also get some information from you actually. Okay, so make this session as a interactive one. Stop me then and there if you have any queries, or you can actually interrupt me actually when like if you have any query actually. Okay. And then actually if you see today's topic is about what we are going to discuss is about impact of cloud computing in Internet of Things. Okay, yeah. Before going into this topic, actually, I will explain about um, myself. I am actually having around 1.5 years of experience in Internet of Things. Currently working as a senior engineer in industrial Internet of Things in L&T Infotech. And actually, I have been actually working on various cloud platforms, which includes IoT components in it. The various cloud platforms, in the sense, actually you all know that actually we have Azure, AWS, and Google Cloud Platform. But apart from that, actually we have some interesting cloud platforms like Clearblade, Cumulocity, and then actually if you see Kingsboard, etc. Okay, actually, yeah. So in this type of platforms and all, actually I have been working, and I also active member in Microsoft Azure community. And then actually I have in AWS. Actually, if you see, I have been a part of the AWS IoT community team. Actually, yeah, actually like this section I have been the part of several communities which speaks about the cloud computing in Internet of Things. Okay, yeah. First of all, actually, if you see first of all, if you see actually here that the topic which we have taken for today to discuss about is called impact of cloud computing in Internet of Things actually. Okay. I would actually want to ask here uh, which one the question like how many of you worked in Azure, Azure or AWS or GCP? Anyone there? Hello?
Excuse me, sir. One of our viewers was saying that your voice was echoing during this. So, one second. I think
Yeah.
if you share your window instead of the whole screen, I think that would be better. One second. I'll.
Yeah, yeah, sure. Okay. Is it fine now?
Yes, sir. I think it seems fine.
Okay. Yeah, actually, here, actually, if you see today in this topic, we are going to see what are the impacts which are created by the cloud computing platforms in Internet of Things. Actually, okay. If we move on to topics, actually, here, if in the topics, if you see, we have some introductions. I need to tell about internets and things and how they interconnected to each other and how they formed in IoT, and then what are the applications we have been using it in an Internet of Things, and then what is really meant by an Internet of Thing, and then how does it how the combination of this cloud computing and internet of thing is creating an impact on our society actually. Okay. uh, if you see what is meant by the internet actually, if you see actually nowadays actually everything actually uh, is possible with the help of internet, but we can live I hope so without the food or water, but actually we can't able to live without the internet nowadays actually, because after covid, the post covid situations, or we actually everyone, each and one of them was working from home, and we are actually adapted to doing online classes, etc. Okay, so internet plays a crucial role in our day-to-day life actually. So in that case actually, how much data can be will be shared on each day in through this internet means actually it's unimaginable actually. Okay, so in that case a large of amount of data which is shared via internet on day-to-day life of a particular person is itself, it's converted into a big data. But if you imagine for the entire world, it might be a huge data which is called as a big data actually. Okay, and we also need actually to store this data which are collected in a large volume, and we need to get it back yeah, whenever we need actually. And we also, this the collection of data and storing of data, it's also, it's not a matter actually, but we need to do, do some analytics with this data to perform some necessary actions, and we need to do some alerts or routine checks based upon the analyzed data actually. Okay, so yeah, in this way the internet is responsible for collecting the data, and it will be utilized in a proper way to give you a some large amount of advantages to manage some important facts or points in your day-to-day life. Okay. Okay, then what is the things means actually, or the term things is nothing but actually, if you see um, the objects which are all here, for example, I can tell it as a things itself actually. Okay, the things which you have in this world actually will be connected to the internet actually. They are that is called actually only the internet of things. Okay, the things which are all connected to the internet, it's day by day increasing actually. Okay, from 2003 to by 2020, if you see, there will be 50 billion devices are currently connected to your internet. Okay, and they all of them are sending the data to your in, internet actually. You have to, yeah, for example, you can take your wearable itself actually. It captures also your yeah, all of your fitness related informations actually. And then actually it will be spending to a particular storage point which is given by your bluetooth or wi-fi or anything. That app stores this data, and next day it will be telling you when compared to last days workout actually. Yeah, today have been, you have been the time which you taken for in workout is more, and this kind of calories you don't when compared to a study like that kind of information you will get it actually. So if you see actually nowadays each and every the things are connected in internet. The fans, yeah, nowadays the fans are even connected to the internet to make them a smarter one. And then actually if you see the if you see that in home automation system, you guys have all of them having I hope so Alexa in your homes or Google Home in your homes actually. So these are all connected in internet by taking day to day data of you, and they will do some analysis. Yeah, for example, if you have your favorite a podcast in your podcast channel is actually it's related to Microsoft means, there will be sometimes yeah, there will be some suggestions coming to you actually when you enter into the podcast channel via Alexa, stating that actually these are these good suggestions we are all we giving to you when based upon your previous interests actually. Okay, so in this place actually, analysis of data is coming into place actually. Okay, that's what it's the internet of things is nothing but it's a combination of collection of things which are connected to the internet actually. Things or assets or anything we can tell like that actually. Okay, and then actually if you see, nowadays actually we guys actually know about what are these sensor devices, and then a which are widely available nowadays, like the development boards like Arduino, and then actually if you have Raspberry Pi, and then Raspberry Pi Pico, and then actually Intel Edison, like that. Actually, we have a lot of development boards available actually. Uh, as a single board computers and microcontrollers also actually, which is connected to various sensor devices. Like sensor device means it's kind of a sensor like a DHT222, like temperature sensor or pressure sensor or a humidity sensor or a heartbeat sensor, O2 sensor actually, like that actually. It can be paired up with your Zigbees also actually, or LoRaWAN, like that actually. Nowadays actually you have a readily available development board with your sensor, which can be integrated with your sensors to get the live data from those particular sensors actually, uh, and that live data can be sent to the cloud as well actually. Okay, so in this way actually, nowadays these sensor devices are widely available actually. If you see some 78 years before, when I was looking for a yeah, when I was yeah, doing my DE, that time actually if you see, my friends and yeah, myself has taken a project which is related to Tamil Nadu State Council, okay, of Science and Technology, which is actually funded under Tamil Nadu government. In that time, if you see, actually, we have they need to build the robot which has to be autonomous, and it should also extinguish the fire without any human intervention actually. Okay, that time and all, if you see some before 8 years or 9 years actually before, actually if you see, that time actually if you see, the availability of these sensors and these development growths are not that much easy. You need to pre-order the things and you need to get the things done actually. But now if you see, actually these sensor devices or development boards are made readily available in Amazon itself actually, so that we can get the things on next day itself actually, or to nearby any famous electronic shops also you can get the things. Okay, why I'm telling this here means actually that much the growth of internet of things has matured in this past 10 to 15 years actually. Okay, if you see here actually, this this slide explains you that actually, yeah, if you have any device which is related to a medical uh, related wearable actually, which is attached to your body, it sends the data continuously to your uh, application, which tends to be collect this data and send it to the internet actually, and it will be stored actually. The sensors which are present in your body is sending the data to a particular application which is installed actually, and then it is sending to the internet, and based upon that actually you have your data here actually. Okay, and then actually from there actually, if you see, if you want to, if you want to perform any data analytics or data science related things based upon the data which is coming from the internet actually, if you do it, and you can also send back the data to the particular person who's having this variable, stating that your DCG is not good, so kindly go and check your doctor, and I also appoint an appointment for you, like that actually. Okay, it's a kind of predictive analytics they have been we can also perform using this uh, data which are collected from this sensors actually, sensors which are attached to these variables. Okay, then actually if you see, in industry wide, if you see actually, we have things connecting to things. That means actually, if I have some you can take the example of an electric car. Sorry, the DV vehicles are nowadays become most popular in the industry. Okay, in the industry actually, if you see how it happens, this DV vehicle um, getting popular day by day, and how much data I need to get will come from these EV vehicles. And sometimes people are telling that we need to have the 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 driverless cars also actually. Okay, if everything we may made into automated means actually, how we can collect the data from these particular vehicles actually means we need to connect all these vehicles to a particular network by means of some protocols like CAN bus. Okay, and then actually they can be able to send the data actually to this particular the particular car, or the vehicle can send the data to the internet actually by means of this protocol, and from that this car's data will be taken actually, and it will be evaluated, and it will be sending to a particular owner actually, who is responsible for this car actually, and they will be telling that how much charge this car is having, yeah, how much uh, uh, distance it can cover with this charge, and where is your location currently, etc. Like this actually, these types of instructions you can get from this, if you connect one or more vehicles actually into a particular network actually. So it's a closed network, and it's, yeah, so that actually you can also, for that particular network, if I have 10 cars of my own actually, if I can, yeah, I can connect all these 10 cars in up to a particular network, and I can get the data of my car alone actually. Okay, that's the thing actually. Connecting n number of devices to the cloud is called things connecting to the things actually. Okay, then actually if you see we are entering into a topic called internet of things actually, that actually if you see what is the impact is happening in your day-to-day life of human life based upon this IoT is actually, it can be considered as a next of internet actually. Okay, and then actually if you see if using this or connecting these things to the internet will be making your communication better, and it will act as a internet networking between your devices and physical objects or things actually. Okay, and then actually if you see the internet of things is nothing but it's called a network of the physical objects. It's true only now, because actually yeah, the devices which are, or vehicles which are present in a particular building, which is being embedded with some electronics or software sensors, and through some network connectivity actually, it is enabled to send the data and collect and exchange the data among these objects actually. Okay, and actually with the integration of all these things to the internet only will be enabled the real world data of your internet of things actually. Okay, what are the key then we are going to see about what are the key requirements of IoT. Your IoT data, actually the things which are sending the data to a particular internet actually network, and from there they are passing it to our cloud now actually, it should possess five key requirements. One is actually if it's security and privacy. The data which is sending from your wearables or from your home or anything to a particular network has to be covered with security. It has to be provided with privacy and security. Next, it needs to be scalable. For example, today I have 10 cars with me, and then I have it. Yeah, tomorrow itself it can be reduced or increased to 100 to 200 cars. Means if I want to connect all this cars to a particular internet of internet only means actually, sorry, not internet, it's a network means actually that network should be a scalable one actually. It needs to withstand what it is. It needs to withstand the n number of devices or things which comes into future actually, and then it should send the real time data. Okay, that things itself means actually the internet of things means actually we need to play with the real time data. Okay, so it needs to send a real time data, and the network should be capable of handling it actually. And then the devices should be intelligent and dynamic, and it should be distributed and decentralized. Okay, if I have a network in India, okay, but my suddenly my network goes down means actually it's a loss of revenue for my organization which continuously collecting the data. Okay, so that only we need to have servers in all over the world which will be decentralized and coupled, and it should be distributed one actually. Okay, these all should be the key requirements of the internet of things actually. And then we are going to see about what are the applications associated with this internet of things actually. Okay, health actually. If you see, we are actually taking an application called from the health industry, that yep, there is a particular device is there. Okay, there is, we are taking some data from the data acquisition actually. From there actually the data is collected and it will be processed to a data concentration on cloudlet actually, and then it should be sent to a internet. From there, from internet it will be passed to a cloud actually, and then from the cloud actually that visualization is presented to a patient or doctor actually. So collecting the data from the things, sending it to the cloud. From cloud it will be sent to any of your cloud providers like Azure or AWS or GCP. From there you need to do some analytics there, and then actually that analyzed data will be presented in the form of visualization to the doctor or the patient actually. This is how the data transformation is happening in your healthcare industry. And now if you see in the in nowadays, if you know that agri tech is uh, becoming most popular, and internet of things is becoming most popular in the agriculture field actually. Okay, if you see here actually, um, we have a lot of WAN is connected in a large field. Okay, and some sensors are, lot of sensors are connected in a particular in agricultural land. From there actually the data will be collected through these servers or through some DPRS systems, and then actually it will be sending it to the continuous data to the farmers or somewhere actually. And then from there actually, once a yield is happened, your you need to store these things actually. Okay, and from there actually it will be sent to your uh, store or godown actually. From there actually it will be packed, and then it will be sent to the transportation, and it will be sent to the stores for selling, and then to the consumers actually. Okay, that is what it's happening in your agri-tech in industry or food industry actually. Next we are going to see actually what are the future of networks. Like nowadays we know actually, the connectivity between your networks are happening actually anytime, any place, and anything. We can connect anything to any network at any time actually. Okay, in anytime connection means actually it's nothing like on the move, outdoors and indoors, night and daytime. At any place means actually the same thing will come, and then actually which things has been connected, whether it will be between your PCs or human to human interaction, or human to thing interaction, or thing to thing interaction actually. Okay, so these three parameters are very much important in your future networks requirement, where anything or any time or any place has to be connected to each other actually. Next we are moving to a topic called cloud computing, which covers actually what is the main impact of cloud computing in your in internet of things actually. Till now, any to the queries you have, guys? Anyone is there? Can I move it?
Yes, there is one question.
Yeah.
Um,
One
so the
second, I'll
question
add
is,
the question as well. I think it's on the stream now. So, yeah, the question is why do we focus more on breakout boards instead of integrated suitable IC on custom PCBs and increasing the efficiency of the whole system? Anirudh asked
Okay.
this question.
Yeah. The first of all, actually, if you are going for in microcontrollers, actually, the breakout boards are important actually. Okay, but instead nowadays in industries actually, if you see the breakout boards are not been will be used only for your the POC purposes actually. Okay, so we are moving towards in edge gateways actually. which is a highly performance supercomputer kind of thing actually, with some 64 GB of RAM, and then actually 512 or to 1 TB SSD hard disk and all actually, which will perform all your analytics actually. So decode, instead of adding a decode goods to your circuit and making it is in an efficient way, we are going ahead with the engaged computers because decode boards we used to nowadays actually for some TOCs or from for some what it will actually the project purposes only actually. But for in when we focus on an industry point of view, we are not using any breakout boards actually. We have been moving towards the customized edge gateways, which will be suitable for some use cases based actually. And actually moreover actually we are mostly focusing about some protocols like modbus or can bus actually in the industry level actually. So if you see if you want to play around with this type of protocols like modbus and can bus actually, you need to upgrade yourself. Yeah, for example, if you take a Raspberry Pi, there won't be any yeah, Doris 232 or Doris 485 ports is available actually. Okay, so in that case I need to put a breakout board for this RS 232. But if I go ahead for a edge computer or a edge gateway means actually this circuit is already available for me actually. This port will be available for me. So if in the moving towards engage gateways will reduce your dependencies on this breakout ports, and it will become a good efficient system as well actually. Is it is it fine guys actually? Yeah, hello, is it fine guys?
Yes, sir. Thank you, sir. There's one more question. One second.
Yeah.
Yeah. So Brajesh has asked, sir, how would you ensure the safety of data transferred?
Yeah, that I will explain actually. The safety of data transfer, if you see actually, uh, yeah, I will go with a basic example actually with some temperature sensor on a development board actually. Okay, for example, you have your cloud platform called Azure. Okay, inside the Azure you have some IoT components services like actually Azure IoT. Okay, inside the Azure IoT, if you see, there are some options called devices, and then IoT Edge actually, like that. In that we need to create a device actually. While creating a device actually, it will ask for your it will create automatically your primary connection string, uh, nor the device can be encrypted with the X509 certificate actually. Once this process is completed actually, I'm telling you how the handshake is happening in a secured manner, yeah, between your Raspberry Pi and your Azure IoT cloud actually. Okay, I have my temperature data here, which is streaming from a temperature sensor by means of some MQTT program which is running inside this Raspberry Pi to push the data to Azure IoT cloud. Okay, once if the handshake has to happen means a device which is already created inside your Azure IoT hub actually has to ensure that the certificate which is present inside your physical device and your IoT hub device are same, and then the handshake will happen. The data will cross to the cloud actually. Okay, is it fine? Actually, this step is common for any cloud platform, including Azure or AWS or GCP, but they have in different names. If you go for AWS, they have a green grass. Okay, in the green grass, we need to have a yeah IoT edge certificates. They will tell actually. Okay, from there the handshake will happen and data will be passed from a device to a cloud by means of uh, uh, by including some security protocols actually. Okay, is it fine?
Yes, sir. I think we can move on. There don't seem to be any more questions. Yes, sir.
Okay, fine. Yeah, actually next to your we are going to see actually what is the convergence of this IoT and big data means the huge amount of data and the cloud actually. if you see here actually, uh, actually this IoT, big data, cloud, and AI and all interconnected. Okay, first of all, we are taking some data from a particular dictionaries. Actually, in the industry level, I will speak from now onwards actually. Okay, yeah, if I have some the chiller plants, okay, the chiller plants actually, yeah, they need to control the emission of this chiller plants actually to avoid the emission of carbon dioxide in a larger manner actually. To do this actually, you need to know what are the parameters needs to be minimized from these chiller plants actually. In that case, what we will do, we will have we'll put some edge gateway, we'll connect the edge gateway to this pillar plans actually, and from each pillar plan actually, uh, the data will be passed on to this edge gateways actually. Okay, the program which is running in this edge gateway, which is used to send the data to the cloud by means of MQTT or TCP/IP or AMQP protocols actually. Okay, the single minute data itself, it will comes as actually some to around if for example I have the chiller plants are connected in a series actually. Okay, and they are sending the data to a particular engage gateway means actually. Okay, this engage gateway actually will get the data for each 20 seconds means actually for each 20-second time interval, the killer plant will send the data to this edge gateway. In that means, if you see, for 1 minute time interval itself, you'll get some huge volume of data. That is the term which is defined here is called the big data. Now, what this engage gateways will do means actually they will push this data to the cloud actually. Okay, by means of the MQTT protocol, which is the program will be running already in this edge gateway to the cloud, and then actually from there actually, okay, the cloud having some components actually. For example, I will tell you in the means of Azure actually. In Azure IoT, we have actually some components like data breaks, blobs, and then actually event hubs actually, which will stream the data directly to your particular data point, and from there actually, from the data store actually, it will take the data and it will be doing some analytics, and it will be presenting to a particular customer actually, or to the end person, to know what are the parameters we need to if you minimize the temperature of the coolant oil, this much carbon dioxide emission we can reduce. Like the analytics we need to perform, and we need to send the things to your end customer actually. Okay, so in this process, if you see, uh, each and everything is important. If I want to perform an IoT project means actually, I need a person who knows very well in the embedded system as well to do their hands-on in their edge gateway, and I need a person who is master in the cloud platform as well to get the data, compute it, and send the and route the data accordingly, and ensure the safety of your and safety and privacy of your data which you are getting actually. And then I need a big data team to process and do some analytics on this data, and I also need a application team, the application development team, who needs to get this data from a particular data store and need to show it to an end customer by means of some dashboards or some the portal kind of thing actually. Okay, so in this case, if you see actually, the IoT is a king which have a big data as a queen, and cloud is a palace actually. Okay, like that only the things are actually going on actually, because the data which we are getting in this IoT are real time data with some insight streams actually. So without each and these components are interconnect to each other to perform a particular um, what it will actually fully accomplished project in an IoT actually. Okay, okay. Actually, now we will see some basics of cloud computing, like what is meant by cloud computing actually. Yeah, yeah. We have some servers placed in a cloud actually, and we'll be utilizing this actually servers for a particular period of time, and we'll be paying this servers for that for particular period of time, where the infrastructure maintenance, security, and all will be taken care by your cloud provider itself. You no need to worry about anything about that actually. And moreover, these servers are anytime available, and it's actually non-demand network access it has actually. So that is what is called as a cloud computing. What are the some of the basic cloud computing characteristics are actually these clouds are should be a transparency to your users and applications actually. Okay, yeah, for example, if I have some I want to build the virtual machine in your cloud platform. I want to know what is the OS they are using, and what is the core actually, what is the cost for per minute or per hour, like that and all. I need to know. And then actually, then we need to have actually, if you see, these servers are built on the clusters of PC servers, and then actually, and they also built with by the combination of some open source softwares as well actually. And then you see actually, if your clients can put their data on the platform, this cloud platform, instead of on their own PC or disk actually, so that your data manipulations and data processings will be done for a particular application on the cloud in a faster manner, and it will be performed in non-demand actually. Okay, got is meant by these convergence approaches actually. If you see actually, cloud centric IoT means actually we need to bring IoT functionalities in cloud actually. Or IoT centric cloud means actually bring cloud functionalities in IoT. As of now actually, in most of the places we are using the IoT centric cloud, because based upon your IoT use case only, the components of the cloud um, will be suggested and architected actually. Okay, next you see, uh, the cloud centric IoT platform actually. What is this cloud centric IoT platform actually? I have actually lot of devices and um, cognitive capability, and then actually some servers and applications which are running individually. When I am trying to combine all these servers to a particular platform, IoT platform, in that way actually, if you see, the platform will become should be a simple, scalable, uh, robust, resilient, truthful, and secure actually for me. Okay, and then actually, if you see, what is a cloud centric IoT means, it will bring the data, your IoT data, into the cloud. The processing and computing of your data actually will be done in the cloud itself by means of some services available in the cloud. And actually, if you see, the services are provided among these objects will be available in the multiple location. For example, if anything happen to a server in a particular location, it will be not be your services will not be completely down. It will be taken care of by some other servers in another location actually. Okay, yeah, then we are going to see about IoT centric cloud computing actually, where actually, if you see, um yeah, we have some apps like the reflex and all actually, which will be in your wearable. In that, if you see actually, the data will be sent to a global cloud, and from a local cloud, the IoT infrastructure layer also sending the data. When it is combining together actually, the situation aware apps will be taking this data, and it will be presenting it as a full cooked data actually to the end users as a presentable manner actually. Okay, if you see what is this IoT centric cloud computing is actually, it will create dense geographical distribution first of all, and actually the processing and storage of data which is nearer to the close to users will be done in your edge gateways itself, and it will have a opportunity to take the services workflow applications which are available in the entire network actually. Okay, and then actually, if you see, what are the cloud service models? Actually, if you see, um, cloud service models are will be classified into three types. One is the software as a service, SaaS; platform as a service, PaaS; infrastructure as a service, called IaaS actually. Okay, what is in with this software, PaaS, and this thing actually? Okay, these, if you see, software as a service means actually it is a kind of actually providers applications. For example, Salesforce CRM and Lotus Live and all. If you see, they are all providers applications actually. Okay, but if you see, PaaS means actually deploy customer created application. That the platform which is used to uh, de- deploy the customer who created customized applications like Google App, Windows, Azure, etc. And then actually, if you see, infrastructure as a service means actually we 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 we, we need to rent the services from a particular cloud providers, and we need to make utilize of it. For example, your virtual machines in Azure and EC2 in your Amazon Web Services actually. Okay, if you see here, yeah, this is your cloud architecture where your presentation data and applications belongs to your SaaS, and APIs, middleware integration things and all will happen in your PaaS, and IaaS will be relying on your facilities, hardware, and connectivities actually. Okay, and then actually, if you see what are the advantages of cloud computing, actually the performance is one of the most um, uh, good thing actually. It's coming in cloud computing because if you see in yeah, if you are if you're using your personal system, and actually when you create a virtual machine in your cloud environment, and if you start working on it, you feel the difference actually how the performance will be. It will take only 10 seconds time to restart your systems, and 5 seconds time to stop and start your systems actually. That much the faster it will be actually. Okay, and we no need to worry about your data reliability or storage capacity or software updates, because these things and all already scalable, and it will be yeah, reliable based upon your costing and tire which you creating in your cloud environment actually. And one more thing is actually computer software cost, because I am if I am using a the virtual machine for 1 hour, actually I have some I configured a virtual machine with me like a 16 GB RAM, and then actually 512 TB SSD and all. For 1 hour it will take only 30 rupees only for me actually. Okay, to utilize it, so I no need to own a machine for some temporary task actually. And if for example, if my project or something is for around 1 month or 2 months, I need to work means, in that time alone I can make the use of these resources in an efficient way, and then you can be able to reduce the cost cuttings actually. Okay, what are the disadvantages means actually, it as usual actually, it's if the internet connection is not there actually, your cloud platform will not will you can't yeah, be able to access your cloud platform. And then I actually and then actually the if your stored data or data which needs to be in a secure manner is not configured with your network security group or some other things actually, your there might be some bit for your data and your stored data also which can be lost. And sometimes actually if your low speed connections, or if you don't have connections means actually your the services or resources inside your cloud computing cannot be a accessible one actually. Okay, yeah, that's all from my side actually. If you guys have any doubt or any queries, yeah, you can yeah, related to IoT or cloud computing, yeah, you can ask me now actually.
Yeah, there is a question on where is the which language is primarily used in IoT, and whether a portion of the code or the entire code is run in cloud.
Okay, regarding the language, if you see, I when I started my career actually I know only .NET actually. Now I know some 5 to 6 programming languages actually. Okay, language which widely actually use this question actually, as of now the world is moving towards Python. Okay, now the trend is trend towards Python, and next it will go for Julia or something. So my thing is actually that the program which is running inside your the edge gateway might be it should be of Node.js, Python, .NET Core, or actually it can be from the the, the Julia embedded C actually. You should be ready to learn the things actually based upon your project requirements. But at this stage, actually, at least please be thorough with your embedded C programming, and then your the Python programming, which should send the data by as a JSON package to the cloud by means of by using the MQTT protocol. Actually, not only ordinary Python programming is not sufficient. Yeah, you need to know how to transfer the data which we are receiving from your sensors and sending it to the cloud actually. And the question is actually the entire cloud won't, when the entire code won't, none of the codes will run in the cloud actually. All the code which needs to take the data from your sensors or machineries will be running inside this edge gateways only actually. Okay, so that's what I'm telling you. You need to be yeah, very much clear about some protocols like what is MQTT and what is TCP/IP, what is AMQP, and then actually you need to know whatever might be the programming language, the way of sending the data to the cloud platform like Azure or AWS actually will be the same by using this MQTT. So try to frame a generic template actually within any of these the programs to send the data to the cloud actually. Okay, and then actually if you see as of now for next to 4 or 5 years you can be rely on the Python itself actually. If you want to learn or concentrate on any particular language means I'm telling, for your placements or anything you can concentrate on Python actually. Okay, any other questions? Hello?
No,
Guys,
sir.
if you have
Doesn't seem
question,
like there's
kindly.
any. Huh?
Hello?
Sorry, sorry. Go ahead. Go ahead.
Guys, if you have any questions, please kindly comment it. Okay, I guess there are no more questions, so we can wrap it up. So,
Okay.
thank you, sir, for sharing your knowledge with all of us, and thank you everyone for attending this Techniture. And stay tuned for similar events. We'll be back.
Yeah, yeah,
Thank you, sir.
thank you everyone actually. Actually if you guys want any guidance or queries you have, you can connect me in LinkedIn actually. Yeah, so that I can guide you from IoT and cloud computing based queries and how to move forward in your career life actually. Okay, thank you so much guys, thank you for this opportunity. Yeah, bye bye.
Thank you, sir.
Thank you. Yeah.
Thank you, sir. Sir, you can share your LinkedIn in the comment section if you want
Yeah, yeah,
in the
sure.
live chat.
Yeah, we'll share it now. Actually, yeah. Thank you so much. Yeah, bye.
Yeah.
In private chat, shall I post it? Actually, is it fine?
Yes, sir. Either place is fine.
Okay. J- Give me a minute. I need to take my URL. Okay.
Okay, sir. Yes.
Uh, yeah, 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 this is my profile link. Actually, you can share with the people. Okay.
Yes, sir.
Yeah, guys, thank you so much for your times. Okay, I will try to give you some more sessions also, if possible, in Azure or AWS, which are related to IoT actually. Okay,
Okay. Thank you, sir. And
thank you.
thank you,
Yeah,
everyone, for tuning in and watching this. Okay.
thank you, everyone.
Bye.
Bye bye. Yeah, bye.